Hello friends, welcome to Chemistry Nuggets. I'm Akanksha and in this video I'm going to explain you the way to solve the questions related to the electron gain enthalpy from the portion periodic classification. So let's take the question first. The first question which is most frequently asked is why 15th group has positive electron gain enthalpy. The second question what we have is, does nitrogen and phosphorus have positive electron gain enthalpy? The third question is, why the electron gain enthalpy of oxygen or fluorine is less negative than that of succeeding elements sulfur or chlorine? So first of all, see question number 1 and 2. Both are actually the same questions. Just the way of asking is different because we can see here 15th group. So in the 15th group itself we have nitrogen and phosphorus. So either the question is asked in this way or in this way, both are same. So let's check out how to solve this. So we are talking about 15th group. 15th group means nitrogen and phosphorus. Nitrogen has 7 electrons, 1 s2, 2 s2, 2 p3. Phosphorus has 15 electrons, 1 s2, 2 s2 and 2 p6, 3 s2 and 3 p3. Now, first of all, understand what is electron gain enthalpy and what is positive and negative electron gain enthalpy. The electron gain enthalpy means when we tries to add an electron to the isolated gaseous atom. So some amount of energy is released or absorbed. Either it will be released or absorbed. Then it is called electron gain enthalpy. So understand the concept, what is electron gain enthalpy? Now come to the point positive and negative. Here we are talking about positive. Why nitrogen and phosphorus is positive? So usually the electron gain enthalpy should be negative. Negative means the energy is released. So adding an electron and energy is released is a normal condition, but sometimes there will be a positive electron gain enthalpy. It means for adding an electron to the system, we need to give an external energy. So when the energy is given, it is called positive, and when it is released from the system, it is called negative. Now come to the point. They are telling group 15th or the nitrogen or phosphorus have the positive electron gain enthalpy. The regular trend says from left to right, electron gain enthalpy increase. The negative one, okay, and from up to down, the will be decrease. Okay. Now, so generally in general trend we are talking about negative electron gain enthalpy, but in between from left to right, suddenly what happens when we are going from the first group to the second, then to the third, the negative amount of electron gain enthalpy increases. Suddenly in the 15th group, it is showing the positive values. Why? After that also in 16th group it is negative, and in 17th group it is more negative. So why this anomalous condition? The anomalous condition is here. See here. P subshell. In case of nitrogen, the last electron is in 1 minute. The last electron is in p subshell. So, see, we can say 2p3 for nitrogen. This will be the condition, and for same here for phosphorus it is 3p3. Let's see what will be the picture here, like this, here, here and here. Now see, we can say this is fully half filled p orbital. Okay, we can say why? Because it has 3 subshells and all are completely filled. So it is, this condition is called completely half filled. So this completely half filled orbital is a very stable condition. That is a stable condition. So nobody who is very stable in their place doesn't want to become unstable as a general rule. So nitrogen and phosphorus and the other elements in the group having the half filled orbital 3p or 2p or p orbital half filled, they doesn't want to disturb their stability, and that's why they doesn't want to take a upcoming new electron. So it is very difficult to add an electron to the group 15 element. That's why we need to give some external energy to add that electron, and that external energy, it means the positive electron gain enthalpy. Concept clear? So that's why we can say group 15 has positive electron gain enthalpy. Understand? Because the energy we need to give because of the half filled orbital. Now come to the question number 2. Why electron gain enthalpy of oxygen or fluorine is less negative than that of succeeding elements sulfur and chlorine? So first of all we will see, write the situation. First oxygen, then fluorine. This is, and this is sulfur below the oxygen, and below the fluorine is chlorine. Now the configuration of this is, we can say 16th group, this is a 17th group, this is second period, and this is third period. Okay, now understand the situation in the periodic table. Now they are telling oxygen or fluorine both has less negative than sulfur or chlorine. Why? Excuse me. So the general trend says from in a period from left to right, it will increase. Delta EGH will, and from up to down, delta EGH will decrease because of the size. Size in the same period from left to right, size will be decreasing. Atomic size decrease, it means the nucleus has more power to attract the upcoming electron. So the nucleus will take it more easily. So the negative electron gain energy should be in the increasing way as the size gets shorter because of the increasing nuclear charge. Now in the same way from up to down, the nuclear charge, although the nuclear charge is increased, but the size itself is increasing because of the number of shells are increasing. So the nucleus and the upcoming electron is very far away from the nucleus. So that nucleus has very less power to attract that coming electron. That's why from coming up to down, lesser the power of attraction nucleus have. So we get negative electron gain energy lesser or in the decreasing order. This is just opposite to the size. Now, according to this rule, fluorine should be have highly negative electron gain enthalpy. It should be oxygen to fluorine and from here to here. So here it is decreasing, it means here it is increasing. So it will be highly electron gain enthalpy will be very highly negative. But they are telling chlorine is more what we can say, chlorine has higher negative electron gain enthalpy. Let's see why. The oxygen or fluorine, the configuration should be, sorry, 1 minute. Let's write the configuration of, first of all, oxygen having 8 electrons. So 1s2, 2s2, 2p4. For sulfur, it has 16 electrons. So 1s2, 2s2, 2p6, 3s2 and 3p4. See, in the same way we can write for fluorine. It is 9 electrons. 1s2, 2s2, 5. And for chlorine, it is 17 electrons. So the configuration should be 1s2, 2s2, 2p6, 3s2 and 3p5. Now look at the C. They are asking why oxygen or fluorine is less negative than the sulfur or chlorine. So first we will talk about oxygen and sulfur. So they are telling oxygen is less negative and sulfur is more. This is the anomalous behavior according to the general trend. Why? The answer is here. Here in this case of oxygen, the upcoming electron is added to the energy level 2. Second, see 2p. The upcoming electron will add up here. We can see like that electron. Okay. And in case of sulfur, the upcoming electron will enter the third level. Okay. So we can say the level 2 is smaller than level 3. So in level 2, the room is small and already some electrons are there. I think in p subshell, p orbital, 4 electrons are there. So when the upcoming electron is entering, they doesn't want to give it a space, because more electron repulsion will be there because of the smaller space. So second level is smaller, and so electron repulsion is there. That's why the upcoming electron will enter in case of sulfur more easily, because in third level the space is much bigger to enter a electron. That's why sulfur have the highly negative electron gain enthalpy in comparison to the oxygen. In the same way, same explanation will be here. Here the upcoming electron will enter in the second level, that electron, and in case of chlorine, it is entering in the third level. So same Second level is smaller, so electron-electron repulsion will be there. The fluorine is very small in structure and it is very difficult to add one more electron in that smaller structure because there is a lot of cluttering effect will be there, more electrons, and they will repel the upcoming electron. They doesn't want to take one more electron. That's why it is difficult to add one electron in comparison to the chlorine. Chlorine has third entering the electron in the third shell, third level. So it is a very big room over there. So chlorine accept is it happily, and it has the higher negative electron gain enthalpy than the fluorine. That is the anomalous behavior according to the general trend. Hope you guys understand the concept and how to solve the questions related to the electron gain enthalpy. So if you have any doubt over any point, make sure you will write a comment to me so that I can explain it to you in a better way. And if you want me to make some more new videos on some specific topic, please again tell me what to do in the comment section. Thank you.